So welcome everyone to our webinar, which we titled Certifying Multicore Timing Analysis for the 178 project. And the aspect of being any practical is that we bring together both the experience of the work of providing the evidence plus the certification advice that we'll get from Reza. Just quickly going through the agenda today. So the first part is going to be Reza Majidi doing his overview of the certification and the guidance from certification authorities. And then I'm going to be talking of the issues of identifying interference channels and how to quantify them. I'm going to show later on some demo material or some video that we have produced on how to apply these principles. And there's going to be a question and answers session at the end. Thank you very much for everyone who has submitted their questions beforehand. If you have any questions during the session, please send them to the list and then we'll moderate them later on. So quick word about who we are. Rapita Systems, we are what we call a solutions company providing on-target software verifications for critical embedded systems. So as part of our positioning, we apply our solutions for the right-hand side of the V model. We have a collection of tools and services, and the package we put in today is how to instantiate our tools to address the issue of CAS32A. Reza.
Yes, thank you. Good morning, good afternoon, and good evening, everybody. My name is Reza Majidi. As Ben mentioned, I'm the CEO of Consanova. We provide engineering services solutions worldwide, in addition to different types of trainings on ARP for systems, safety, software in terms of DO-178C, DO-254. We do a lot of gap analysis, safety reliabilities. And as you can see, today I'm talking with you from UK. My hometown is in San Diego, and I'm departing tomorrow. So thank you for being patient that I'm not in the office. As Gia mentioned, we're going to talk briefly about the certification aspects of Multicore within the realms of the avionics and capturing the highlights of the CAS32A. I think that we have arranged a good seminar, a workshop, that we will talk in details about the CAS32 implications and the Multicore timing analysis. The first one will be in Barcelona. I think it's in April 16th. All of you will be invited, and we're going to send emails. So please do sign up to have a hands-on workshop, and we can meet with you face-to-face. Both Dr. Guillaume and myself will be in that session. Okay. The challenges of the multi-core. So we have different type of multi-cores, and each architecture, each type of multi-core would have its own case. So there is no single solution that we can provide or we can talk about. And that's another reason that CAS32A, it's presented itself as a very generic, not dependent on any specific architecture of multi-core. So you could have a symmetric multi-core processor with one RTOS, basically managing the partitioning, managing the robustness, timing, and resources, or you could have asymmetric partitioning with real-time operating systems loaded to each core, and how that real-time operating system is governing the OFPs or application software are very different and unique for each case. So why do we have to deal with this multi-core? Well, there is two reasons. I believe the main reason is the industry size and industry evolution. Avionics domain compared to other gaming, automotive is a very tiny market, and the market moves forward. So we have the obsolescence of the single core, very difficult to get those these days. So we as a avionics domain, our engineers, we have to follow this realm. In addition, we are moving forward from the federated system to more of IMA concepts, and then more up into the cabinet-based advanced avionics. We're going to put more functionality into our in each card, so capability increases and the higher demand of a speed and multi processes and applications. So for those two main reasons, we have to address this, and certification authorities, FAA and EASA, have provided guidelines for this purpose. If you ask the manufacturer about the interferences, which is the main topic of this webinar, they would say, well, those are the performance bottleneck. And if I ask you guys, all audience here, you would say, especially the safety folks on this webinar, you would say these are dysfunctional behavior. But the goal is that these failure modes related to this shared resources or interferences, they could have caused loss of integrity or availability of the systems within the aircraft. So if you go back to the single core or the typical avionics, the safety concept starting from the FHA, PSSA, SSA, and the fault tree analysis still is valid and needs to be done from a top-down and bottom-up approach applies to the MCPs or multi-cores. More difficult so, especially when you move to a design assurance level A, DAL A. Okay, so the issue is the lack of predictability, right? The fail-safe principle that should prevent a single hazards or single fault to create a catastrophic or hazardous situation has to still be intact. Microprocessors, the multi-core processors do have different type of what we call the black box components in terms of peripherals that could create those type of interferences. And we also have to deal with their complex configuration settings and make sure that those are documented and those are safeguarded for high criticality level of the systems. Well, the reason we have to deal with that is the safety. Every avionics systems have to finish their task or functions within a deadline, within an allocated time. And when you add all of these complexities, a missing single deadline could cause a catastrophic effect. So we have to deal with that. In terms of the compliance, we should have a software architecture and a hardware architecture in mind. So there should be a system approach. We should, CAS 32A imposes and requires to implement a robust partitioning, especially when you apply real-time operating systems to your software and to your implementation. And at the end, deterministic behavior of microprocessors are in question. So in terms of the challenges, the good news is that CAS 32A really provided a good guidelines. There are certification memorandums by EASA, and there are informal or formal industry groups that are developed to discuss this usage. Multi-cores have been certified in avionics, mostly PowerPCs, some may be Intel-based, different types in terms of heterogeneous or homogeneous, even multi-threading with disabled or enabled. So each scenario, as we said, they're very different. CAS 32A indicates that applicability of these objectives to cover the safe behavior of these processors should apply to design assurance level C and above, okay? Some of the microprocessors are exempt, and those are the lockstep nature of some of the microprocessors. And CAS 32A does not talk about dynamic feature allocations of the software or hyper-threading. So those